So what do we expect from you today?
The best from us.
The best. I wish you well.
Thank you, madam.
Presbyterian Boys Senior High School, Legon. Presbyterian Boys Senior High School, Legon is represented by
Akpaluko Fimaoli, final year. Even your Nsmq final year.
You're welcome, gentlemen.
Thank you.
And how are you?
Fine, thank you.
A little bit about your last contest. What happened?
In our last contest, we faced Keta and Jache Pramso, and by God's grace, God saw us through, and we won the contest. It was a very close one, but
a close one.
Yes.
Okay.
Thank God.
And the semi-finals. What does it feel like to be in the semi-finals?
We feel excited, and it really shows that God has really shown His favor on us. Then we pray that you continue to share His favor upon us so that we go to the final.
All right. Expectations from you today?
We pray for victory.
Victory. In that case, let me wish you well. Kumasi High School. Kumasi High School is represented by
Amajeri, final year.
Bonnie works for JC, final year.
You're welcome, gentlemen.
Thank you, madam.
How are you?
You're fine by God's grace.
Good. Your last contest.
Okay.
What happened?
Our last contest, we met Tia Mas Fomina and Wesley Girls High School, and we won by God's grace. It wasn't that easy, but God saw us through our last contest to the semi-final.
All right. And what does it feel? What does it feel like to be in the semi-finals?
Of the competition.
Okay.
Expectations.
As we are noted for our usual mission, we have prayed, we have practiced. Madam, we are going to win.
Yes, wishes. We've met the contestants. All three schools are promising wins. We shall find out soon enough. But before I sit down, I would like to acknowledge that the National Science and Math Quiz is sponsored by the Ghana Education Service through the Conference of Heads of Assisted Secondary Schools. We also have support from TIGO, GOIL, Prudential Life Insurance, Accra College of Medicine, GCB Bank, and City FM. We are produced by Prime Time. My name is Dr. Elsie Ifa Kaufman. I'm a senior lecturer in the Department of Biomedical Engineering, University of Ghana, and I'm your quiz mistress. Thank you. Contestants, the contest comes to you in 5 rounds. The first round is a round for fundamental concepts. Simple and direct questions that require simple and direct answers from you. If you answer your major question correctly, 3 points. If the question is incorrectly answered, it becomes available to the 2 other schools. A school may ring and attempt an answer. If the answer is right, a bonus point. If the answer is incorrect, it fetches a penalty point. For questions which require calculations, you have 30 seconds in which to present your answer. If there are no calculations, you have 10 seconds to do so. All questions, all of them are to be attempted once only. Best wishes to all 3 schools. For the first set of questions, I have a preamble. You're going to have 30 seconds of time, and I'm going to begin with you, Presbyterian boys. Preamble to all schools. Please listen carefully. Use division to write the rational function as a quotient plus remainder over divisor. Do you have your preamble? Good. So now, Presbyterian boys, the expression 2x plus 1 divided by the expression x minus 2. Yes, Mauli.
1 plus the expression x plus 3 over the expression x minus 2.
That's incorrect. Yeah,
Over x minus 2.
you're right. With the same preamble, the expression x plus 1 over the expression x minus 1. Bright.
Madam, we have 1 plus 2 over x minus 1.
Yes. With the same preamble, the expression 6x plus 5 over the expression 2x plus 1. Yes, Bonnie.
3 plus 2 over 2x plus 1.
You're right. For the next set, it's a single question to all 3 schools. When I get to your school, please give me a right answer so that I can move on for the next different and right answer. This is the question. And please be specific with your answer. 4 parts of the nephron of kidneys are involved in active transport for either reabsorption or secretion. Name one, only one part each. And I'm starting with you, Presbyterian boys. Yes, Anna?
Loop of Henley.
I'm not accepting that. St. Thomas Aquinas? Bright?
The distal convoluted tubule.
Yes. Massey High School? Yes, Jerry?
Yep, the proximal convoluted tubule.
Yes. The other two are the ascending loop of Henle, and then the collecting duct. I asked you to be specific. "30 seconds. Preamble to all schools. You will be given the atomic number of two elements. On the basis of their electronic configurations, state the type of bond expected to be formed between them." Did you get your preamble? Good. Presbyterian boys, element X with atomic number 6 and element Y with atomic number 14. Senna,
Madam, equivalent bond.
you're right. St. Thomas Aquinas, elements X and Y with atomic numbers 11 and 17 respectively. Yes, Christopher.
Ionic bond.
Yes. Elements X and Y with atomic numbers 8 and 20 respectively. Jerry.
Ionic bond. Ionic bond.
Yes. "30 seconds. Find the of the hydrogen atom.
The power negative 10 meters.
That's incorrect. For a bonus. The right answer is 846 picometers, or 8.46 times 10 to the power negative 10 meters. St. Thomas Aquinas, a 20 Newton centripetal force acts on a 0.5 kilogram object moving in a circle of radius 2 meters. Find the kinetic energy of the object. Yes, Bright?
20 joules.
You're right. The coefficient of restitution for the head-on collision between a 3.0 kilogram object moving at 4.0 meters per second and a stationary 5.0 kilogram object is 0.60. Find the velocity of the initially stationary object after the collision. Yes, Jerry.
2.4 meters per second.
You're right. Next set, 30 seconds. Find the measure of the interior angle of a regular polygon with 24 sides. Yes, Senna.
3,960 degrees.
That's incorrect. The right answer is 165 degrees. St. Thomas Aquinas, Find the number n of sides of a regular polygon with interior angle of measure 170 degrees. Find the sum of the degree measures of the interior angles of a polygon with 52 sides. Bonnie,
9,000 degrees.
you're right. Preamble to all schools. Preamble. Describe each one of the following types of ribs that form the rib cage of humans. Did you get your preamble? Good. Presbyterian boys. True ribs. Yes, Anna.
They are attached to the sternum bone, and also they arise from the thoracic vertebra.
I'll give you one. They have a direct attachment to the sternum through the costal cartilage. St. Thomas Aquinas, false ribs. Yes, Bright?
Well, false ribs are the type of ribs that join to each other before attaching to the sternum, and they are also attached to the back or the vertebral column. So they are mainly joined by cartilage, and mostly they are the last two pairs of ribs.
One. All right. These ribs unite indirectly or not at all with the sternum. And they are after the true ones, the next three pairs. Kumasi High School, with the same preamble, floating ribs. Yes, Jerry.
The floating ribs, they are the ones that are usually considered to be sometimes false, and also they don't have direct contact with the sternum, and also some also have some attachment by the tubercular and the capitular facets of the thoracic cavity in the vertebral column.
I'll give you one. These are the last two pair of ribs, right? They have no attachment to the sternum. No attachment to the sternum. You're talking about indirect, going about it. Okay. So if you wanted to add more, they have only one attachment dorsally to the vertebrae and have very thin bone tissue locked in muscle as they extend laterally. All right, next set. Presbyterian boys, why must energy be supplied to an atom of an element for an electron to be removed? Senna.
Electrons move in stationary states about the nucleus of an atom, and in this state, they do not lose energy. So in order for transition to occur between states, electrons need to gain energy. So for them to leave their shells, they need to be supplied with energy to overcome the potential energy, the the force of attraction, the potential energy between provided by the electrostatic force of attraction between the nucleus and the electron. So as they gain energy, then the forces weaken.
Okay,
Then they leave their shell.
finally. On and on and on. Something that you can simply summarize in one sentence. Overcome the attraction between the nucleus and the electron. Eventually, you said it. St. Thomas Aquinas. Although it takes relatively little energy to remove an electron from an atom, the ionization energy of an element becomes significant. Why? Yes, Christopher.
Okay, madam, this is because ionization energy is the amount of energy needed to remove 1 mole of electron from the valence shell of 1 mole of isolated gaseous species. So since, though like removing an electron from the outermost shell of a single atom is insignificant, the ionization energy of 1 mole of an atom is significant as compared to when you take a single atom and you are removing an electron from it.
Yes. Because 1 mole, you have to think of Avogadro's number. All right. Kumasi High. Experimental values of the first ionization energies for the first 20 elements, that is hydrogen to calcium, show several clear patterns. Give any three patterns. Yes, Jerry.
Okay, from lithium to beryllium, the ionization energy increases. From beryllium to boron, it is found that of boron is less than that of beryllium. And also from oxygen to fluorine, from oxygen to fluorine, ionization energy also increases.
I'm going to give you one. Because you are mixing up the patterns, you are mixing them up, you are not making them stand out clearly. Okay, so there are actually 4 of them, and then I was asking you for 3. Okay, so the clear patterns. The first ionization energy increases drastically as we go across a period. Drastically. The second one, there is a big drop in the first ionization energy as we go from the end of one period to the beginning of the next period. So there is a big drop. The third one, there is a gradual decrease as we go down a group. And then the last one, there are minor exceptions in a period. And you did mention this. This is why I'm giving you one. So, for example, you have beryllium, boron, or magnesium and aluminum. You mentioned the exceptions. Okay, so you see they are very clear. All right. 30 seconds. Presbyterian boys. The coefficient of restitution for the head-on collision between a 2.0 kilogram object moving at 5.0 meters per second and a stationary 4.0 kilogram object is 0.80. Find the velocity of the initially stationary object after the collision. Mauli.
3.2 meters per second.
That's incorrect. Yes, which of you? Bright.
4.0 meters per second.
No. The right answer is 3.0 meters per second. Your major question, St. Thomas Aquinas. Find the radius of the 7th electron orbit in the Bohr model of the hydrogen atom. Yes, Christopher.
Madam, 2,587 picometers.
Again.
2,587 picometers.
Okay. Kumasi High School. The kinetic energy of a 0.5 kilogram object moving in a circle of radius 4 meters is 100 joule. Find the magnitude of the centripetal force on the object. Yes, Bonnie.
50 newtons.
You're right. Next set 30 seconds with a preamble. Preamble to all schools. Solve the equation for x. Presbyterian boys, log to the base 3 of the expression x plus 2 plus log to the base 3 of the expression x plus 10 equals 2 times log to the base 3 of the expression x plus 4. Mauli.
X is equal to -1.
You are right. With the same preamble. 2 multiplied by log to the base 3 of the expression x minus 2 minus log to the base 3 of the expression x minus 4 is equal to 2. Christopher.
X is equal to 5.
2 out of 3. X is equal to 5 or 8. Kumasi High School. Log to the base 5 of the expression x squared plus 2x plus 5 minus log to the base 5 of the expression x minus 5 is equal to 2. No, for a bonus. X is equal to 10 or 13. The next one, the next set is actually a single question to all three schools. When I get to your school, please give me a right answer so I can move on for the next right answer. This is the question. Give one function, only one, of the umbilical cord of mammals. Presbyterian boys. Senna.
The umbilical cord consists of blood vessels, and particularly the umbilical vein, which transport food materials from the
One.
mother.
Yes. St. Thomas. Yes, Bright.
The umbilical cord connects the fetus to the mother, and through this cord, useful substances are sent into the fetus, and waste substances are excreted.
One. Kumase High. Yes, Jerry.
The umbilical cord serves as a passageway for the diffusion of dissolved oxygen in the maternal blood into the fetus, and also diffusion of carbon dioxide from the fetus.
Gaseous exchange. Actually, there were a whole lot of them. A whole lot of them. It contains blood vessels, the umbilical artery, the iliac arteries, umbilical veins. It joins the placenta to the embryo. It's a passage for nutrients from mother to fetus. Passage of excretory substances from fetus to mother for final discharge, for gaseous exchange. Passage of antibodies from mother to fetus for protection of fetus against diseases, and a source of stem cells. Those of us doing tissue engineering, it's a very good source of stem cells for tissue engineering. Next set, 30 seconds. Presbyterian boys, consider the reaction. 4NH3 gas plus 5O2 gas going to 4NO gas plus 6H2O gas, and the delta H is equal to negative 910 kilojoule per mole. Calculate the enthalpy of formation of NH3 gas. If the enthalpies of formation of NO gas and H2O gas are 90.3 kilojoule per mole and negative 240 kilojoule per mole, respectively. For bonus, the right answer is negative 42.2 kilojoule per mole. St. Thomas, consider the reaction 3NO2 gas plus H2O liquid going to 2HNO3 aqueous